Thank you so much. We have a lot to cover. I think I'm gonna say differently everything that you said a little bit about myself. I've been doing this for a while, and I'm mostly a startup guy, doing everything around field engineering, field CTO, and sales and pre-sales and customer success at 3 companies throughout the last I think almost 20 years now, which is one of them was sold to SAP, the other one was sold to IBM, and the last one is LakeFS, which is the company that I work with right now, which is an open source solution for Git for data. We actually reviewed LakeFS before, right here in this session. I do wonder, out of curiosity, if it's the same folks or is it different folks? Can I ask? Oh, there we go. We have a Q&A here already. Where can I see the Q&A? Are there any groups outside of the USS? I'm in Canada, Montreal, and want to learn about your program. Who doesn't have US work permit? I think this is a question for you. Yeah, thank you. So I'll let you answer. Thank you about that.
So yeah, we have programs for Canada. We have income share agreement for Canada and US people. So you're welcome to go and make the application if you find it interesting. Yep. Sorry, that was okay. Go ahead.
No, not a problem. I just want to know where to focus on today. How much to focus on this? So here's the question, because the last session we were very much MLOps specific, or I'll say data scientist specific. This one is a little bit more of a generic MLOps conversation, specifically about working with Airflow DAGs. So I have, I guess, 2 questions. I don't know if will the people on this, will everybody be able to raise their hand, for example, so I can just count quickly?
Yeah, they can do raise hand.
Okay, so there we go. So if I can ask, I'm gonna lower everybody's hands, and if I can ask, who here is familiar with Airflow? Okay, great.
Wow,
a lot of people are familiar with Airflow. Good, fantastic. And I'm gonna, great. And was anybody here on the last LakeFS conversation, or anybody familiar with LakeFS? Okay, so I'm gonna have to go on that from. Okay, so I'm gonna speak about both these things, and we're gonna talk about troubleshooting data with Airflow and do it together. And the idea behind this one is to do it more of a following the request from last time is to do it more of like a workshop. So I'm going to kind of walk you through everything that I'm doing. There's going to be very little slides and a lot of code and GitHub and things like that for everybody to start. But okay, let's start. I'm assuming, who's familiar with what an ETL is? Okay, great, fantastic. Everybody's, or a lot of people. So yeah, the last years, right? There's been solutions out there like Airflow, for example, which are orchestration solution that are helping us run very complicated pipelines. So there's the basic idea of an ETL, extract, transform, load, which is extracting the data from somewhere, transforming it a little bit, and then loading it back for someone to be able to use it. That's kind of the basic pipeline that anybody can do. And that's like, if you open the Airflow, which is an open source solution for an orchestration by a company called Astronomer. It's highly popular. It's, I think, probably the most popular one. There's also an Airflow solution provided by Google. There's also an Airflow solution provided by AWS, MWAA. It's called Managed Workflow Orchestration Airflow. I think that's what MWAA stands for. So it's highly common, and what it helps people do is, in the world of data, is to run very complicated pipelines in an efficient way. And like over time, the complexity of those became higher and higher. So what you see here is a DAG. A DAG is an Airflow program that basically runs multiple tasks, one after the other. And over time, those just became a lot more complicated. So you will load data from one place and you'll transform it, and then you'll wait for data that comes with another place. And there's a complete ecosystem of things that you would expect from an orchestration systems that are here, such as operators and triggers and you know, just the ability to create very complicated pipelines in an easy way. And the price of that complexity is, well, what this complexity gives you, of course, is the ability to run very complicated ETLs that before were very hard to do in an automatic way, right? A lot of asynchronous versus synchronous things that can run in parallel at scale. I mean, this writing code to do something like this would be very, very complicated. Therefore, using something like Airflow becomes very, very easy to run complicated things. The price of that, on the other hand, is what do you do when something goes bad, right? So people that works with Airflow, and it looks like many of ours, will use an orchestration tool, and then, you know, step 55 out of 200 will suddenly become red because something broken. And troubleshooting and reproducing that is something very difficult to do. And typically the process is to look at logs, try and identify an issue, review the DAG from beginning to end, troubleshoot the data as it evolutionizes, meaning what did the data look like at the beginning? What did the data look like? Can Airflow be used with Azure Data Factory or in place of Informatica? Yes, Airflow can be used with data with Azure Data Factory. For the question that was asked, in place of Informatica, I'm not really sure about Informatica and what that does. So on that question, I won't be able to answer you. I apologize about that. But it definitely can work with Azure Data Factory. It's actually very common to use Airflow with solutions of that nature. Informatica is for Oracle. I'm on the record. I'm less familiar with Oracle and modern data lake solutions aspect of it. Yeah, so today we're going to talk about this thing. I'm running an Airflow DAG. And by the way, this doesn't have to be Airflow. This can be any type of orchestration. I'm having issues, and I want to be able to troubleshoot them quickly without the need to kind of manually try and figure out how the data changed over time, and then rerun everything from the beginning in isolation. And of course, I have an interest here, right? I'm speaking with you today about a solution that I'm part of the development of, which is an open source solution, and I think that's why we have this stage. It's something that any one of you can use for free. But basically, what LakeFS does is allow you to run data as code. It's something that sits on top of an object store. Quick show of hand, who here knows what an object store is? Object storage. Okay, we got a little bit. Okay, a little bit. So it's worth mentioning that an object store is a common object, like the most common object store that people refer to is S3, Amazon simple storage service. But there are every cloud provider has their own object store solution, like Azure Blob, like Google Cloud Storage, and there are many on-prem object storage as well, like Min.io, like Dell ECS, like NetApp Storage Grid, like Hitachi, I forgot the name. Like basically, almost every storage provider today also provides an object store because it's meant to be a cost-effective way to support massive throughput. So when you start working with big data, then object store is a great way to design what you call a data lake, right? Which is a way to just throw a lot of data all the time, either by streaming or copying data on top of that object store. So a data scientist will often find himself working with can Lake absolutely Databricks exclusively runs on top of object store. So that's a great question. Databricks the compute engine that will run on top of object store, on top of S3 or Azure Blob or Google Storage or Min.io or any other object store, for the question that was in the chat. So yes, Databricks will work on an object store. It's actually exactly for that use case, right? You might have Delta tables or Parquet files, and the way that it works is that you constantly write those into the object store in a very high throughput manner. So that's a great question. And what we do is we sit on top of the object store itself, which is, again, the most common way for data scientists, for data lakes to be designed today. And we provide Git capabilities to that object store. Again, show of hand, who's familiar with Git? I'm expecting a lot right now. Okay, great. Yeah, okay, great. So I appreciate that. Thank you, folks. Git. So everybody's familiar with the ability to branch and merge and roll back, which works for files. What it doesn't work for is it doesn't work for big data, right? Going and creating a branch for 5,000 files and modifying them, Git is not meant to do that. Not to mention 500 million files, right? And data scientists many times need to work with thousands, if not tens of thousands or hundreds of thousands of images and annotations and data of all source or pick and choose file from massive object stores, and versioning that is impossible with Git. However, imagine that you can take your data and you can create a branch of it, and you can work on it in isolation and create commits just like you will do with code. And when you're done with the transformation of the data, you can merge it back into prod, and you can again promote data just like you will promote code. So that's the idea behind LakeFS. And then the ecosystem of tools that you have in your environment can access the data through the LakeFS API and get those versioning capabilities. And then from a refactoring point of view, if before we were accessing a collection on a bucket, this is the common way that someone will access like an S3 bucket, for example. You will just give a path where your data sets are. For example, if you use Databricks, this foo directory might include a list of Parquet files, right? Or that is a Delta table, for example. And with LakeFS, you will include the name of a branch or a commit identifier, like main, test, dev, prod, or a commit identifier will be prod yesterday at 5 p.m. before an ETL ran, or prod yesterday at 10 p.m. after an ETL finished. And then the Git actions themselves, you can run them through command line, through Python code within a notebook, which I think is very relevant for data scientists, or from a web interface as well. Questions so far beyond the good questions that we had so far? Okay. So another thing about object stores, which I think is very important, object stores are immutable. What that means is that you cannot modify files on object store. And that's kind of the trade-off of this design, and why it works so effectively for data lakes, and why it has massive amount of throughputs. You can't edit a file. If you want to change a file, then de facto what you do is you write a new version of that file every time. That's why solutions like if you work with Databricks again, and you work with Parquet files, that's very effective because it's a lot of smaller files as opposed to one giant file that you likely are going to have to modify. So the way that it works is that folks will have a lot of files sitting on top of their object store, right? So I'll have an S3 bucket or an Azure Blob storage or a Google storage, and I'll have files here. And in LakeFS, every commit in LakeFS will have a collection of pointers to objects that sit on top of that managed bucket. And because the object store is immutable, we do copy on write, right? That's another phrase that you might want to be familiar with. Copy on write. This means that, let's say someone went and changed this file. When a new file was created, we will write this new file, and the next commit will point to that additional file. But files that did not change, like these 3 files over here, you will have multiple commits pointing to the same physical objects. Why is this useful? Why is this design useful? It's useful because if I want to create a branch, and we have thousands of users, it's an open source solution, right? Thousands of users that I'm aware of. Some of them have petabytes of lakes. creating a branch will always take milliseconds. At 500 petabytes, it will take milliseconds to create a branch because it is a metadata-only operation, because I'm not actually copying anything. I'm just creating a set of pointers to the same environment. For the same reason, it also saves on storage, because what happens is that you can have many isolated versions of your data, right, without ever copying any file. And this is very useful for data pipelines, like the Apache Apache Airflow use case that we're speaking about right now. And it's very useful also for like standard data science operations, where an individual wants to get a copy of 1,000 images, 50 videos, annotation files, and all of that, and put them locally so they can work on it. Imagine doing that without ever copying anything. So that's also very useful. And the other reason that it saves on storage is that by nature and data lakes, most of the times you have a big chunk of files that are static files, and then a smaller subset of the files that are added and removed on a regular basis. So this allows us to go back in time without the need to take snapshots of the same files over and over again. So because I'm actually deduplicating the object store over time, and that's a very efficient use of storage, which object store, as I mentioned before, is inexpensive, but it's definitely not free, right? And the ability to work this way is very helpful. Pause for questions. Questions yet? Okay, fantastic. So there were a lot of questions as we went, so I'm not as far as where I wanted to be. But I do want to walk you through, like, technically, step by step, a way to bring an environment here from start to finish, all using open source. And in this environment, we'll create for you. You will have an Airflow environment that you can use. You will have a LakeFS environment that you can use. You will have DAGs that you can work with. So it's a really great way to get familiar with this. And there's two examples that I'm going to walk you through right now. After I'll walk you through the setup, so you'll see how to do that. And that can be useful for many reasons, not necessarily for LakeFS as well. One is we're going to show a way to run a DAG in isolation. So that's like if someone has an existing DAG and they just want to run it in isolation, they will do it. And the other one is we'll show how to run a DAG and run Git commands as we go. I won't go to, let me jump directly to the code part, even though I can explain this a little bit more. And depending how far we'll get with our timeline, I'll go back to the presentation. Okay, so let's do that. Again, I'm pausing for questions. Okay, good. So there's two things that we're going to do right now. We're going to bring up Airflow with a Jupyter notebook with everything that we need around it using a sample repository. Anybody here doesn't have who's familiar with Docker and the ability to run Docker containers? Okay, fantastic. Not everybody. So this will be oh, okay, no, a lot more people. Okay, great, fantastic. So my only prerequisite for this demo is that you do need to run Docker locally, right? So Docker is a way to run containers locally. This basically takes away a lot of the dependencies, problems that you typically otherwise had in terms of running on different operating systems. And it's a very easy way to kind of deploy a bunch of things together and run them in a containerized, no pun intended, way locally. LakeFS has a bunch of samples. We're going to go to this. This is, like I said, this is open source. This is GitHub. Everybody has access for this. You can fork it and change the code if you want. This is completely for you. Anybody that wants to use it. It also happens to be a good way to kind of learn LakeFS, of course. But I'm posting the link right now here in the chat, so everybody can have this link. And this is a standalone example of a Jupyter notebook together with Airflow. I'm going to go to the example Airflow 01. There's a lot of other examples here because that's what we're going to speak about today. And if I scroll down here, you will see different versions, the explanation of how to set this up. So basically, I actually already have this running, but maybe for the sake of this demo, I'm going to stop it and I'm going to, oh, server error. Oh my goodness, how did that happen? That's weird. The beautiful aspects of live demos. I wanted to show you how I do this from beginning, but it might be that I'm going to need. Okay, what I'm going to do is I'm going to restart my Docker. Okay. So while everything is easy, some things are not working. Here we go. Let me delete this, and I'm going to walk you through everything from start to finish. Okay, so I'm going to open my terminal. And here we go. So the first thing, let me make this a little bit bigger here. The first thing that we need to do is we need to copy the environment. Since I already have it, once again, and I want to do this very much like a workshop. So I'll really walk you through all the steps from start to finish. Sample. Okay. Okay, so I'm going to remove my directory. AKFS samples, AKFS samples. There we go. And we're going to really follow these instructions. So we're going to clone this repository, AKFS samples. Then we're going to go to the path of what we did right now. So I'm literally just going to my terminal and I'm pasting this. And what this does is it will copy all the samples over. And then it will go to my directory. And then the next thing that we're going to do is we're going to build this project. Funny. Thanks for the shout out, Michael. I appreciate it. I will downloading this. See if download. And by the way, folks, feel free to do this on your side as I'm simultaneously as I do this on my side. Okay, so I have everything here, and now in my directory, I'm under standalone examples, Airflow 01. And now I'm going to build the Docker container and I'm going to run it, right? So this is the command for that. Now, for me, this will be pretty fast, as you can see, because I ran this before, meaning like I already have all the dependencies. When you run this locally by you, it might take, it most probably will take a lot more time because it actually needs to go and download a lot of packages that I already have on my computer. So even if it takes 30 minutes, like that's okay. The next time it's going to take 30 seconds or 1 second, as you can see over here, right? So once I did that, what I got here is I got this Jupyter notebook. Here it is. So it's pretty cool because I have here a example with different notebooks, like new DAG or existing DAG examples that we can run, including actually an Airflow environment that you can run in a click of a button. I'll show you how that works soon. The other thing that we will need, we have Airflow, we have Jupyter Notebook, we will also need the LakeFS server. There's a few ways to get started with LakeFS server. If you go to docs.lakefs.io, then on the quick start, you can see here, once again, a single Docker command that you can use to run LakeFS. So again, one command, you run LakeFS. When you run this Docker run command with LakeFS, this is a configuration that will actually run LakeFS against your local storage, not necessarily against an object store. So if you don't have an object store, you can use that. But if you do have an object store, I'll jump all the way to the end. You can also run the same command with keys to your object store that will allow you to run LakeFS still locally in a very easy way, not using like you don't need to use Helm charts, and you don't have to know Kubernetes, and you don't have to know anything like advanced DevOps to do this, but you can run this against your storage easily. That's actually what I'm going to do. I'm going to run this environment. I'm going to run this terminal. Oh, nope. Sorry. Terminal. Here we go. Let's do a new window. Okay. And I'm going to run this. I'm going to run this Docker command. And here we go. Sorry, just because I didn't want to share my permissions. So here it is. I have a LakeFS environment. Let's go to LakeFS. You see, you can complete the setup process by going here. So I'm going to go and complete the setup process. It's asking me for some details. Okay. And now I'm getting here credentials. Let's go to login. Have your access key and a secret key. Here we go. So here's LakeFS. So I have an open source, completely free LakeFS environment that I'm running. I have an open source, completely free Jupyter notebook that I'm running. I have an open source Airflow that I'm running. Great way for anybody that wants to get familiar with orchestration and data pipelines to play with. So now what I'm going to do is I'm going to open this. We'll start with existing DAG. So the idea here is that someone has a DAG, right? Remember, a DAG is one of these things, right? It's like a group of tasks, one after the other, that Airflow is going to orchestrate with us. What I want to do is I want to run this DAG in isolation. So I want to take my data set, create a branch, i.e. create a zero-copy clone of my data set, run that DAG in isolation, and when I'm done with the DAG, I'm going to merge the data back into prod. Okay, so let's see how we do that. So what do I need? I need a LakeFS endpoint. So for the LakeFS endpoint, if I run this on a URL on the cloud somewhere, I can give my URL. Specifically, since I'm running this in a local container, I'm going to use this way. This is just the syntax to work, so the containers will be able to speak with each other, because I'm running right now 2 containers. One is the LakeFS integration demo. It's using these ports. And I have the LakeFS server that's using 8000 and the local host. If I just give here local host, then the container, it will say within this container, and it's not going to find it. So I'm going to use host.docker.internal 8000. Okay. And now I'm going to need a LakeFS access key and a LakeFS storage key. We just got those over here as a reminder. So I'm going to copy those over. And I'm going to run this. You can run this by clicking play or shift enter to execute this. I'm sure that, by the way, is anybody seeing a notebook for the first? Is everybody who's familiar with notebooks in general, not necessarily Jupyter Notebook? Okay, great. Okay, great. So great. Okay, good. Practically everybody, good. That's what I expected. I just want to make sure. So I'm going to run this. And I'm going to create here a repo called Airflow existing DAG repo, right? And then I'm going to set some parameters like the names of branches and things like that. The next thing that I'm going to do is I'm going to give a storage namespace for my LakeFS repository. The LakeFS repository is a logical term. It's a group of data sets that work together. It needs to have some sort of storage namespace. I connected this to my AWS, so I'm going to use an S3 example. Obviously, you can either connect this to your Azure, AWS, Google storage, or you can work with the local storage. When you run LakeFS, if you create a sample repository if you create a sample repository at the beginning, then it will create for you the example with everything that you need, and you can copy from there the path. For me, I'm using my bucket, which is Doris 3, and then we'll have here hello Airflow troubleshoot. Just so I'll remember to deal this later, right? Okay. Okay, let's do that. And here I'm going to run this command, and this will basically start Airflow for me. So this is pretty cool because right now this will run my my task, including starting Airflow for me. So we're going to have an Airflow environment soon that we can work with. This might take a few seconds. Again, it also depends on the strength of your computer, right? So here Airflow started. We have Airflow. We can see that soon. Okay. And great. And by the way, if you want to see these setup tracks, you can click on setup here, and you can see the common setups for Airflow. They're going to be under here, and everything that is done in the background to actually set up the Airflow environment. So that can be very useful for you as well. Okay, so we've done that. And what I'm going to do right now is I'm going to first create a repository. So here's a repository. So now if I go to my LakeFS environment, I'm going to see, let me refresh this, that I'm going to see that I have a, did I create a repository? Yeah, that I have a repository called Airflow existing DAG repo. It's empty. It has no data in it right now. And then the next thing that I'm going to do is I'm going to take this DAG. There's a wrapper DAG. That what this DAG does is it creates a branch, runs an existing DAG, and then commits and merge like what we spoke about before, right? And what it's going to use is the Airflow ETL DAG. So Airflow comes out of the box with an ETL that does very, very basic transformation that we're going to wrap against. If you want to see it, you can literally click on this link and you can get the Airflow UI. It's Airflow. Airflow is the password for the one that's running here locally. And you can see what I have here is I'm going to create an ETL branch, trigger the DAG, and then commit it and merge it back in. Very, very, very simple ETL, right? So let's go and trigger this with LakeFS. So I'm starting this right now, right? And as this is running, we can go to the wrapper DAG and we can look at it. And this is it. So you can see you can see right now it's running the existing DAG itself, created a branch. Once it's finished, it's going to commit the changes. There we go, and done. Everything is successful. So everything ran, my entire thing ran from start to finish. Now, what's cool about this is that, first of all, by the way, if I want to go to the trigger DAG, this is an Airflow thing. I can go and I can click on the trigger DAG and I can see the actual DAG also that this triggered, which is pretty cool. I can see the graph of that DAG, the extract, transform, load. Again, very, very basic DAG that we can see here, but it's a great way to look at, to get this data. But also I can, regarding the context of what we're speaking of right now, I can go from Airflow into LakeFS. So we triggered this DAG and then we committed the change, right? So I can go here to LakeFS. Well, I need to go to localhost. This is where running everything actually does have some. Let's copy this as we should directly into LakeFS. Oh, 120. Yeah, here we go. Oh, what did I do? Stories. There we go. So I can link directly from Airflow into LakeFS, and I can see the commit using Airflow, right? And this is a bidirectional bidirectional integration. I can also go from LakeFS and go to the Airflow DAG that executed the data. Let's talk about this a little bit. Why is this useful? Okay. I mean, I want to understand where a data set came from, right? I see that I have here some sort of file, right? Like total order value.txt that gives me the total order value. Okay, that's the ETL. One of the things I can do with LakeFS is I can use the Git blame functionality. The blame functionality in Git, for those that are not familiar, is you choose a file and then it can show you all the changes in that file and each person that made those changes as you go. Obviously, when you work on top of a data lake in an object store, that makes a little bit less sense because the file doesn't change, right? You create a file once and the object store is immutable. Having said that, you still want to know what committed this data. So I can go to that blame and I can see that this commit identifier created this data using Airflow. I can go to the Airflow UI and I can see exactly, all the details of what this did. Like, where did this data come from, right? So I can go directly into Airflow like we saw before and see which execution actually created this. So this is the simple example, right? If we go back to the data, that I can write a DAG in isolation. The reason this is so powerful is that we showed a very simple ETL, right, that did like one thing. But you can have hundreds of steps here. And if something fails midway, you don't want to expose this data. You want to stop. You want to be able to troubleshoot, okay? And not create a mess inside your production data sets. So that's why this isolation is so powerful for us. Questions so far? I know that I know that we're going very tactical, very technically inside. So if you have any questions, feel free to bring them up. If not, once again, this is all also, if you want to follow up on this later, this is also all available for you in the links that I shared before. Let's do something else. Let's do something a little bit more complicated right now. So I'm going to go back to my notebooks, and I'm going to work right now with a new DAG. So let's say that I'm creating a new DAG. Let me copy the same. We're going to use the same LakeFS server that we just created, right? And I'm going to create a repo called Airflow new DAG repo, right? And again, I'm going to put that in my bucket. New DAG Airflow repo over 31. Yeah. Let's do this. And once again, we're going to now actually introduce a new DAG into Airflow. You're going to see that. That's a little bit more complicated. We're going to see that soon, and we're going to work with that. So that's the next thing that we're going to do. And then I'm going to create a new LakeFS repository in our environment. We're almost done. Here we go. And good. There we go. Okay, so I'm going to create a new repository. So now when we go to LakeFS, we're going to have a new repository called LakeFS new DAG repo. Once again, empty, right? And let's close this. Let's close this. Let's go here. Let's go here. Yeah. And this repo, this DAG is a lot more complicated. It has a lot more steps. We're going to see this in a while. So I have new DAG. Too many open things. Let me close everything here. Okay. Okay. Perfect. You can, again, we can review this program here if you wanted to. Let me show you what it looks like. This is the new DAG. This starts to be something that pipelines will look like. So the idea here is that I can make changes in parallel, right? That's where pipelining becomes more powerful using things like Airflow. So I'm actually going to run 3 types of tasks in parallel. One is going to be this one over here, and then simultaneously I'll run a couple of multi-step tasks, and then another task over here. And these will be things like repartitioning data, making sure that the data is right. We're sensing for files to be uploaded. I don't want to spend, we don't have time to go into the internal of an Airflow DAG, but it's a great example for someone that wants to get to know something, to open this. It's all open, all the data is here, all the code is here, you can go and you can play with it. What I'm going to do here is I'm going to use an input data set like fstest.csv, and I'm going to run this DAG over the input data set. I probably should have done that before, because that takes a little bit more time to do that. So let's run this. This will take a few minutes to run. Here we go. So as you can see the color here is the bright green that you see over here of the things that are running right now. And the green are successful things that already ran. So you can see what already finished and what already ran, and you can see the tasks that are currently running, right? And this is continuously refreshes, and everything is running. My different ETL tasks are running. They're running in parallel, as you can imagine, as you can see over here. And this is an example of what like a data engineer will look at, right? This will run in parallel. This will have multiple steps, and it's often not completely straightforward and simple. As this runs, you can also see different branches in LakeFS, right? So each one of these tasks run at its own individual branch, and you can see the data set as it changes throughout this task. So someone wrote a new CSV, someone changed something, and we have the complete commit history for each one of those things, right? So someone committed the first step, then committed the second step, the second step, then the third step. And we can see for each one of them, the data sets that were created, each one in the CSV. And once again, the link to the Airflow DAG that executed this, which is the same one that we see today. And it looks like this finally finished. And it's merged everything back to prod. So that means that if I go and I look at main right now, I can see all the data sets as they created, and I can figure out for each data point, if I needed it, exactly where it came from in Airflow, which is super, super powerful. But this is where everything worked. We have 5 more minutes. So let's talk about what happens when things are not working. So what I'm going to do right now is I'm going to add a CSV file that is missing one column, right? So this will basically just mess up everything. And then I'm going to trigger the same DAG again, right? Part of this DAG is going to repartition, and it's going to look for 5 columns, and I'm just going to have 4 columns or something like that. And we're going to see that in this case, something here is going to eventually turn red, right? For running everything, and a step is going to fail at the end. And again, this is something that happens every day for data engineers, where something doesn't work and you need to troubleshoot. Often you actually need to undo all the changes that were done before. We don't have to do that here because everything is done in isolation in a separate branch, but troubleshooting what was the problem is a very complicated thing to do. And here I have a failed task, right? So if we look at the red, we have a failed task. So one of the things I can do is I can just go to the commit before this failed task and go and look at the data once again. Sorry, let's look at why do something I'm copying wrong here, but for the sake of this exam. Where's my LakeFS? What happened to my LakeFS? I don't know. Let me copy here, sorry. think I closed the LakeFS UI by accident. Okay, here's my new DAG repo. And I have here now new branches of the DAGs that I created right now. We did not promote new data to production because the DAG failed. And once again, let's go to our failed DAG, wherever that was. There we go. And I'm going to copy this over to LakeFS. And here we can see the data sets with the failed commit. And I can look at the data. And once again, this is supposed to have 5 columns and it only has 4. And that's why everything fails in a very straightforward way that otherwise it's very difficult to do. So I know that we only have 3 minutes left. So I want to kind of sum up what we spoke about today. And by the way, everything that we spoke about today, like once again, is available through the LakeFS open source solution, through Airflow open source solution, through Jupyter, which is open source. So everybody can just run this as they wanted to. But I hope this helps understand ways to troubleshoot data pipelines in an easy way, reproducible way. I'm going to use the last 2 minutes to see if there's any questions. Going once. Going twice. Okay, fantastic. Can you speak about using unstructured data? Yeah, Chase, that's a fantastic question. So yeah, what I mean for LakeFS, because what we spoke about, right, the way that it works, it really doesn't matter. The format doesn't work. You can work with structured and unstructured data, videos, images, annotation files, which is structured, right? So this is everything that we spoke about is completely relevant to unstructured data as well. Can you build dashboards on top of Airflow? You absolutely can. They have a lot of dashboards also. I will say that I have no agenda here, right? I don't represent Airflow in any shape or form, but just so you know, the different offerings around Airflow, whether that's Google, whether that's Amazon, whether that's Astronomer, all have some advanced dashboarding capabilities as well. So those are really easy ways to come. But just so you know, like for every one of these DAGs, I can see like, you know, the different tasks, how many times it ran, which one of them failed, which one of them didn't make it. Like, and there's a lot of even the open source solution has a lot of dashboarding in place. Okay, so with a minute to spare, thank you all very much for your questions and interest today. This was fun. I appreciate it.
Okay. Thank you, Ido, for the presentation. Can you hear me well?
Yeah, I can hear you.
Okay, great. So it was great. Thanks everyone for participating. If you have any questions to Ido, you can send the email a message to him, and as well as to us. We can extend the message to him as well. Hope to see you in our next event. Bye.
Very much. Bye.
Bye.